welcome to the second half of Chapter 8, Types of Chemical Reactions. In the previous videos, we examined our learning targets and we examined the types of different organic reactions. And again, in our future videos, by the time we finish this chapter, our learning targets will be completed. So let's venture off and look into organic reactions. So the first type of organic reaction that we're going to look at is the hydrogenation reaction. So a characteristic of the hydrogenation reaction is that there is an unsaturated alkene as a reactant. One of the other reactants is hydrogen in the presence of platinum metal. Now, platinum metal here is functioning as a catalyst. We'll talk more about what a catalyst is later on. But also, the product that results is an unsaturated hydrocarbon, where those two hydrogen that were previously part of the hydrogen molecule have attached themselves to the new hydrocarbon. So in the classic case of hydrogenation, you go from an unsaturated alkene to a saturated alkane by the addition of hydrogen. Another type of organic reaction is the substitution reaction. So taking a look on the left, further in the reactants, we have a chloroalkane. The chloroalkane is going to react with hydrobromic acid. The hydrobromic acid, in this case, produces, instead of having a chlorine attached, having a Br attached to the haloalkane. And the byproduct of the reaction is hydrochloric acid. So characteristics in this reaction is that a haloalkane reacting with a haloacid to give a substituted haloalkane. So all what's happened is literally, just as we've said before, there's a lack of creativity here, where this is simply swapping one halogen for the other, one halogen from the product to a different halogen in the reactant. Another type of reaction are the so-called elimination reactions. So here we start out with a haloalkane, once again, in the presence of sodium hydroxide, reacting with sodium hydroxide, to give us an alkene. This time, this is the reverse process of what we saw with hydrogenation. Here we have a haloalkane losing water and sodium chloride. This process can also be referred to as a dehydration reaction because you are producing water as a byproduct. Water is eliminated from the reaction. So we call these elimination reactions, where we go from a haloalkane to an alkene. Another type of organic reaction is a so-called esterification reaction. The esterification reaction has really a number of important characteristics. Now, this particular reaction is very important in biological systems, where carboxylic acid shown here, reacts with an alcohol in the presence of typically an acid such as sulfuric acid. This type of esterification reaction produces an ester. So again, a lack of creativity in the name. This functional group shown here is an ester, and the byproduct is water. So this is also called a dehydration process. So the carboxylic acid reacts with an alcohol to produce an ester and water. Another type of organic reaction is one that is an exceptionally important industrial process. Now recently, there's been a near nationwide ban on those single-use plastic bags. Those single-use plastic bags are typically made out of materials that come from fossil fuels, typically molecules such as ethene and polyethylene, ethene and propylene, which are alkene compounds. So here in this polymerization reaction, we take a simple alkene, and under very specific conditions, which are not listed here because they're very, very specific, this process, this alkene bonds to itself to make what we call a polymer. Now, a polymer is simply defined as a molecule that bonds to itself, reacts with itself, and makes multiples of itself. So if we take a look here, the N value on the lower right-hand corner shown here says that this particular unit, the CH2 unit, repeats as many times as necessary. So we can have long chain polymers, short chain polymers, and depending on the use of the polymer will depend on the length of the chain. So for example, typically very fragile plastic bags are very short-chained alkenes, very short-chained polymers. And then you also have high-density polyethylene, HPDE. Okay, those are the type of molecules that go for more building materials. For example, the chair that you might be sitting on if you're sitting on a plastic chair, or your pen may be made out of that particular plastic material. Again, this particular reaction is very important in industrial processes. So another type of organic reaction is also an important industrial reaction, but for other reasons. This process is called fermentation. Now, fermentation takes a simple sugar. Here we have glucose, which is C6H12O6, that reacts under enzymatic conditions to give us ethanol or any alcohol, or in this case, this particular alcohol, ethanol, and water. So it's a simple sugar that makes alcohol and carbon dioxide. This process is what makes beer carbonated. And this process is what's used to make all the different types of alcohol that we see, from spirits to beers to malts. This process is what is single-handedly responsible for it. So this is also an important industrial process. This other type of reaction, called saponification, gets its name from an old world process. This is essentially characteristically reverse process of esterification. So here on the left side, we see that we have an ester. Here's the characteristic ester functional group. In the presence of sodium hydroxide, produces a sodium salt of the same acid and the alcohol byproduct. So this process is known as saponification because previously this was a way that we made soap. So these alkanes, the ester on this side, would be long chain esters. So instead of having just CH3 here, they'd be long fatty chains, typically that were resultant from animal fats, such as bacon grease or lard, any sort of animal fat that we had that would be digested as a result of processing meat. So the leftover from the butcher scraps, that would be used to make soap. So in the presence of sodium hydroxide, it would break down this ester to form this portion here, which would be the soap moiety, but it would have a very long extending chain that would form soap. And you'd have a byproduct of typically what's called glycerol or just any alcohol here. So the process is known as saponification because it was previously used for soap in old world understandings. We now move on to this addition reaction. Again, here, very uncharacteristic in terms of its creativity. We have an alkene on the left and an alkene in the presence of a halogen. We can change this halogen to be chlorine or iodine also, and we add across the double bond. So there are the two bromines that are added across the double bond. So if we start out with an alkene, we literally just add the two bromines to the product. So our product is a haloalkane product. So now let's pause for a minute and take a moment for you to pause the video here and attempt this question to identify what reaction is shown here. So in this particular reaction, we have methane reacting with Br2. Br2 produces a product of bromomethane and hydrogen bromide. Now this process is exactly the same of the last process that we just saw, where we're adding here. Okay, that's what you would think, that we're just adding to here, but in fact we're not just adding, we are substituting. Here we're removing one of the hydrogens to form in the product, and we are ending up with one of the bromines here. So if you take a look at, we have bromine being substituted in this process. So this would be classified as a substitution reaction. In this particular process, this question is asking us, the process of joining small molecules together into larger ones is called, well, we discussed that, where the single process reaction, these would be known as polymerization reactions, where we're gluing together small molecules like ethene and making much longer, more sophisticated molecules. This problem is asking us, this reaction is an example of. So we're taking here an acid and reacting it with an alcohol. This process is what we called esterification. Now please remember that saponification is the reverse of this process. So if this were flipped around, This would be a saponification reaction, but in fact, it is an esterification reaction. And that brings us to the end of our practice problems and takes us through a little bit more than halfway of Chapter 8.